Welcome back. Let us go to the question. A solid disk and a ring, both of radius 10 cm, are placed on a horizontal table simultaneously with initial angular speed equal to 10 pi rad per second. Which of the two will start to roll earlier? The coefficient of anesthetic friction is given by mu k equals 0.2. Friction is the cause of motion here. So using Newton's law of motion, we can write F equals ma. Now in place of F, we can write mu k, that is this kinetic friction, into mg, which is equals to ma, or we get the value of A to be mu k into g. Now by the equation of motion, we can write V equals u plus at, or V equals mu k gt. The torque is given by tau equals I alpha. Now as tau is equal to I alpha, we can replace tau by R into F and it becomes negative I alpha, or in place of this we can write mu k mg R, that is the value of F, mu k mg into R equals minus I alpha. So we get the value of alpha, that is minus mu k mgr divided by I. Now using the equation of rotational motion, we can write omega equals omega naught plus alpha t, that is omega equals to omega naught plus minus mu k mgr divided by I into t. We put the value of alpha here. So the condition for rolling is V equals omega r. So we can write this, putting the value of omega here. For the ring, the moment of inertia is m. So we have a t equals r omega naught divided by 2 mu k into g. Putting in all these values, we get the t to be 0.8 second. Now in case of the disk, the moment of inertia is I equals half mr square, and t is r omega naught divided by 3 mu k into g. Putting in all the values, we get the t to be 0.53 second. Hence the disk will start rolling first.